right, let's take a look at the graphs here on the screen. This video is going to talk about parallel and perpendicular lines. So the first thing we need to do is graph some lines and see how we can relate these ideas. So first of all, f of x up here, you'll notice has a slope of -1/2. It's in a y equals mx plus b form, right? All three of these graphs actually are in slope-intercept form. So again, we can quickly identify the intercept being b up here at 4, and again a slope of a -1/2. Now if you're not familiar with slope-intercept form, make sure you go back and watch one of the other videos that will talk a little bit about that slope-intercept form equation. It just makes things very simple to graph, right? Again, we can start at our y-intercept, but count out our slope, down 1, right 2, down 1, right 2, to graph f of x. And nicely, each of these graphs is in function form, so we can kind of give them a name. You'll notice that again, g of x now has a slope of 2 and a y-intercept of 8. So I'm going to start up here at 8 and go. Again, 2 is 2 over 1, so up 2, right 1. Or since I'm out of room there, I can go down and left as far as that goes. But again, when I go to label this line, since it has a different name, it's not just y equals, that one I can call g of x. And then finally, h of x here has a slope of -1/2, which you'll notice is the same slope, right, that we had up there at f of x, right, -1/2. Only I'm starting at a different place. I'm going to start down at -7 on the y-axis. But again, I'm going to go down 1, right 2, down 1, right 2, which just tells me that h of x and f of x, since they're sort of traveling in the same way, right, sort of along the same track, if you will, just starting at different places, those two graphs would be parallel, as it says down here. We know that f of x is parallel to h of x because we know that parallel lines have the same slope, -1/2, and different y-intercepts. Now our real question here is, how does g of x relate? Well, g of x, you'll notice the blue line travels completely in the other direction. The other two are sort of falling very slowly, down 1, right 2, down 1, right 2, sort of a nicely sloping, negatively sloping line. Whereas g of x is rising much more quickly, right? It's going up 2, right 1, up 2, right 1. Its ratio is much larger. And it's traveling in a positive direction. Well, that's why these are called perpendicular lines. And actually the technical definition of a perpendicular line is not only are they traveling in different directions, they're also actually traveling in perfectly right angles. Now you can always talk to your teacher about the geometry behind that, of it being exactly a right-angled line, how we could prove that that's the case. But algebraically, the big thing we want to notice is that perpendicular lines have negative reciprocal slopes. So you'll notice that up here again, this was a slope of -1/2. Well, the slope of g of x was positive 2 over 1. So not only is it positive versus negative, but it's the reciprocal. 1 over 2 became 2 over 1. If two lines have negative reciprocal slopes, again, they're called perpendicular lines. They're going to be lines that cross at a perfect 90-degree angle. Not just close to it, a perfect 90-degree angle. So let's take a look. A couple of the things your book is going to ask you to do, or that your teacher might ask you to do, is identify the slope of a line, and then tell me what type of slope would a parallel line to that or a perpendicular line to that have. Well, for the first example up here, you'll notice again this is y equals mx plus b, so the slope is very simply 7. Well, that means that a parallel line to that would be 7, or the slope would be, right? The slope of that line would be 7. And a perpendicular line, right, to that would have a slope of, well, instead of +7, it would be a negative. Instead of 7 over 1, it's going to be 1 over 7. Now the next line, you'll notice, is in point slope form. So again, that's y minus y1 equal to the slope times x minus x1. Now I'm not that worried about the x1, y1, the fact that that goes through the point -8, -3. What I do want to know is that it had a slope of -9, which means a parallel line would also have a slope of -9, and a perpendicular line, right, m equals, would be a positive instead of negative. And again, if that's -9 over 1, we're going to be a positive 1 over 9. We're going to flip that fraction over and again make the negative into a positive. The next line is a horizontal line. You might remember that it's y equals mx plus b, only you'll notice there is no x, right? The m value in mx must have been 0. The m must have been a 0. Horizontal lines have a slope of 0. Any parallel line to a horizontal is also horizontal, so it's going to have a slope of 0. Keep that same slope, right, to be a parallel line. Now, perpendicular gets a little tricky. If you think of that parallel line, well, that's 0 over anything. Well, flip that over. First of all, negative 0 is still 0. But if we flip that over, right, even if we call it negative, it doesn't really matter. Anything divided by 0 is going to be undefined, which makes sense when you remember that vertical lines are undefined slopes, right, or have undefined slopes. So to be perpendicular to a horizontal line would have to be a vertical line, right? The only way to have a right angle going on there. And then the last one, we just have to identify the slope very quickly. So I'm going to subtract 15x from both sides, because it's the easiest way to identify that slope is to get this into y equals mx plus b form. Standard form as it's written, right, with x and y on the same side is not as helpful. But again, if I divide by 3, y will equal negative 5x plus 7. We know that the slope then is negative 5. A parallel line would have a slope of negative 5. And a perpendicular line would be positive, right? Instead of a negative slope, it's going to be a positive, and instead of 5 over 1, it will be 1 over 5. Again, perpendicular slopes are negative reciprocals of the original. Now, the more important points, or the more important type of equations that this is going to ask you, or your book probably will ask you to do, is finding the equation of, right, a line that's parallel or perpendicular to an original. Well, if it's parallel, again, all we have to do is first identify the slope of the given line. Well, for us right now, it would be 3, and we want to go through this other point. So probably the quickest way to find the b value, right, if I want to be y equals mx plus b, I want to be slope-intercept form. I want to be y equals mx plus b, right? Well, let's plug in what we know. I know that y is negative 5 with a slope of 3 when x is negative 3, and I don't know the y-intercept, right? This x value wasn't 0, so I do not know b yet. I need to go find it. So negative 5 equals negative 9 plus b. We're going to add 9 to both sides and find out that b equals 4. So our parallel line, y equals, will have the same slope as the original, 3 times x, but be through the point 0, 4, right? We have a y-intercept of 4, according to what we figured out in the problem there. The same idea can be used at the bottom. Now you'll notice this time we want standard form. This one's going to take us a little longer, but again, we'll walk you through it here. But we also want to be perpendicular. So if the original slope, right, was m equals 2/3, the slope of the line that we want then, right, the perpendicular slope, right, would be m equals a negative 3/2. Right? We're going to flip it over and we're going to make it negative. Now, to figure out the b value, we could do what we did up top, so feel free to use that method, get it into slope-intercept form. But I'm going to go ahead and use point slope form. I know a point and I know a slope. So I'm going to say y plus 5 equals negative 3/2 times x minus 4, right? Y minus the y value, y minus a negative made positive, so y plus 5, negative 3/2 for the slope, and x minus 4. To get ourselves into slope-intercept form, right, working our way towards standard, we're going to first distribute. So this is negative 3/2 x. Negative and negative makes plus, and 3/2 of 4 would be 6. And then finally subtract our 5 here. So we're going to be y equals negative 3/2 x plus 1. I'm going to transfer that up here because now if we want standard form, we just need to adjust this equation a little bit. Okay? We need to get x and y on the same side. So the first thing I'm going to do is I'm going to add 3/2 x to both sides. So therefore 3/2 x plus y equals 1. but now I also want to get rid of that half on the bottom. Again, I'm not worried about the 3, but standard form, we should have integer coefficients. So I'm going to multiply a 2 on both sides of my equation. 2 times 3 halves just becomes 3. 2 times 1 is going to be 2y, and 2 times 1 on the right would be a 2. We've got our standard form, right? X plus y equals constant. Notice they've got coefficients, but those coefficients are not fractions or decimals. So we got our standard form equation right there. If you have any questions about parallel or perpendicular lines, make sure you talk to your teacher. Otherwise, feel free to watch the video and have a great day.